Here we have one differential equation. Here a0 is a constant, a1 is a constant, a2 is a constant, an minus 1 is a constant, an is a constant. Constant means any number that is a constant. And here the nth derivative of y, and again one reduce, that is a n minus 1 derivative of y, n minus 2 derivative of y, and so on till dy by dx. At the end we get the y, and this is all equals to the f of x. This is the f of x. This type of differential equation is called nth order linear differential equation with constant coefficients. Let dny on dxn equals to dny. Let dn minus 1 upon dxn minus 1 equals to d raised to n minus y, and so on. Dy by dx equals to dy. This is a shortcut denotation for the different derivatives. Therefore, above equation can be written as a naught dny plus a1 d raised to n minus y plus a2 d raised to n minus 2y plus, and so on, an minus 1 dy plus any equals to f of x. Now we can take y common, so it becomes like this: a1 d raised to n minus 1 plus a2 d raised to n minus 2, and so on, an minus 1 d plus an, writing y as a common, equals to f of x. Let an d raised to n plus a1 d raised to n minus 1, a2 d raised to n minus 2, an minus 1 d plus an. Let us denote it by something like phi of d. So implies phi of dy equals to f of x. Now the solution of this equation is given by y equals to yc plus yp. What is yc and what is yp? Suppose f of x equals to 0, then what do you get here? F of dy equals to 0. Then the solution of phi of d. Phi of d is a polynomial. The solution of phi of d equals to 0. Then that solution is called yc. So yc is the solution with f of x equals to 0, where yc is nothing but complementary function. Yc is selected such that phi of d multiplied by yc equals to 0. And what is yp? Yp is nothing but particular integral. And phi of d into yp equals to f of x. So to find the solution of given differential equation, we need to find yc and yp. So we have phi of d into yc equals to 0 and phi of d into yp equals to f of x. Call it 1 and call it second equation. Now adding both of them, we get phi of d yc plus phi of d into yp equals to f of x. Now taking phi of d common, So we get yc plus yp equals to f of x, implies y equals to yc plus yp satisfies f of d y equals to f of x, implies yc plus yp is complete solution. Therefore, to solve the equation phi of dy equals to f of x, we have to find out yc, we have to find out yp, then the final answer is y equals to yc plus yp, where yc is called complementary function and yp is called particular integral. First of all, let us understand how to find complementary function. To find complementary function, we got here certain steps. We must follow these steps here. So what are the steps? First of all, we equate phi of d equals to 0. Phi of d equals to 0 is nothing but called auxiliary equation. Now treating f of d as the ordinary nth order polynomial. Now step 2, we factorize phi of d and we find out the factors. What are the factors? D minus m1, d minus m2, d minus m3 and so on d m minus equals to 0. So we get the various values of m1, m2, m3. After that, the general solution of this auxiliary equation phi of d into y is given by yc. What is the yc? Yc nothing but c1 e raised to m1x, c2 e raised to m2x, c3 into e raised to m3x and so on till n, that is a cn e raised to mnx. By using this formula, we can find out yc, that is a complementary function. There are the certain rules we need to follow while finding out the value of yc. What are these rules? Rule number 1, if the roots of the auxiliary equation are real and different, let us call them first root is m1, second root m2, third root is m3 and so on. We got n root. Then what is value of yc? So yc is given as a c1 into e raised to m1x plus c2 e raised to m2x and so on up to the cn e raised to mnx. This is a very common and useful rule. Now rule number 2. In the rule number 2, if the roots are repeated, if the two roots are equal, the two answers are equal, let us say m1 and m2 both the answers are equal. Rest of the answers are different like m3, m4, m5 are not equal, but any two answers are equal. Let us say m1 and m2 are equal. In that case, yc given by yc equals to c1x plus c2 e raised to m1x plus c3 e raised to m3x and so on up to the n term. Now, the rule number 3. The rule number 3, if the roots are complex numbers, let us say the two complex number m1 equals to alpha plus I beta and m2 equals to alpha minus I beta. These are the two complex numbers. These are the two roots. So in that case, yc equals to e raised to alpha x multiplied by a cos beta x plus b into sin beta x, where a equals to c1 plus c2 and b equals to I into c1 minus c2. Now rule number 4, if the imaginary roots are repeated, that alpha plus I beta, alpha plus or minus beta x are repeated twice. So when they are repeated twice, then what is the answer? Yc equals to e raised to alpha x, and here what will get here? c1x plus c2 cos beta x and c3x plus c4 multiplied by sin beta x. Because here the roots are repeated twice. Let us summarize these 4 rules in short and sweet. Here I have prepared a chart. talking about 4 rules. The rule number 1, rule number 2, rule number 3 and rule number 4. In rule number 1, this is the auxiliary equation and we already factorized it, and we have taken only 2 roots here. There can be 3 roots, 4 root, 5 root, any number of roots, but I have taken only 2 roots here. Then yc equals to c1 e raised to m1x plus c2 e raised to m2x. For example, I got here d minus 1, d minus 2, d minus 3 equals to 0. Here are the 3 roots are possible. Call them as m1 is equal to 1, m2 equals to 2 and m3 equals to 3. Then how to write the yc? Yc is written as a c1 e raised to m1x, c2 into e raised to m2x plus c3 into e raised to m3x. Therefore yc given as a c1 e raised to x plus c2 e raised to 2x plus c3 e raised to 3x. This is all rule number 1. Don't worry, I will solve few problems for you to make you better understanding. Now rule number 2. Here rule number 2, what is that? The roots are repeated. You see that in the first bracket we got d minus m1, second bracket we got d minus m1. That means the 2 roots are repeated. Then how to write the yc? Yc equals to c1x plus c2 into e raised to m1x plus c3 into e raised to m2x. Example I have taken here, m1 answer is 4, m2 answer is 4. So 2 roots are repeated. Then what is the yc value? Yc equals to c1x plus c2 into e raised to 4x plus c3 e raised to 7x. Now rule number 3. Roots are imaginary roots. Example, d equals to alpha plus I beta. That is, m value is alpha plus I beta. So what is the solution? Y equals to e raised to alpha x and in the bracket c1 cos beta x plus c2 sin beta x. Here I got example, d square plus 9 equals to 0. So we got here the d equals to plus or minus 3i, that is alpha plus or minus beta plus or minus I beta. That means rule is true for plus and the rule is true for minus. So alpha value is 0 here and the beta value is 3. So solution is e raised to 0x c1 cos beta x plus c2 sin beta x. If there is minus, what to do? That would be the cos of minus theta, that equals to minus cos theta. Rule number 4. Imaginary roots are repeated. Suppose the result is d is equal to alpha plus I beta. Then we can write here y equals to yc. It is the value of yc. So here is the yc. So yc equals to e raised to alpha x and in the bracket will come c1x plus c2 cos beta x and c3x plus c4 sin beta x. So these are the 4 rules to example 1. Solve differential equation d2y upon dx2 plus dy by dx equals to x. Solution, d2y by dx2 plus dy by dx equals to x. This can be written as d2y plus dy equals to x. Taking y common equals to x. Now comparing with phi of d y equals to f of x implies phi of d equals to d square plus d and f of x equals to x. So auxiliary equation is phi of d. Now equating phi of d to 0, therefore we get d square plus d equals to 0. Finding the factors, taking d common implies d equals to 0 and d equals to minus 1, implies m1 equals to 0 and m2 equals to minus 1. Now to find yc, what is the formula? C1 e raised to m1x plus C2 e raised to m2x. Therefore yc equals to C1 e raised to 0x plus C2 e raised to minus x. Therefore yc equals to C1 plus C2 e raised to minus x. Now we need to find out yp. To find yp nothing but particular integral. So what is the formula for yp? That is the particular integral is nothing but given by 1 upon phi of d into f of x. Therefore yp equals to 1 upon phi of d, that is the d into d plus 1 into f of x. F of x nothing but x here. Now so we have the yp equals to 1 upon d into d plus 1 into x. Now we go for partial fractions. That is 1 upon d into d plus 1 equals to a upon d plus b upon d plus 1. Therefore 1 upon d into d plus 1 equals to 1 upon d minus 1 upon d plus 1. These are required partial fractions. Therefore here we can write yp equals to 1 upon d minus 1 upon d plus 1 into x. That is equals to 1 upon d into x minus 1 upon d plus 1 into x. Yp 1 upon d into f of x equals to integration of f of x. Therefore 1 upon d into x equals to integration of x dx. Also 1 upon d plus m into f of x equals to e raised to minus mx integration e raised to mx f of x dx. Therefore 1 upon d plus 1 into x equals to e raised to minus x integration e raised to x into x dx. Therefore yp equals to integration of x dx minus e raised to minus x integration of e raised to x into x dx. That is equals to integration of x is x square by 2 minus e raised to minus x. Here we apply product rule of integration by using LIATE rule. So x integration of e raised to x dx minus integration, here is the derivative of x with respect to x, integration of e raised to x dx again dx. This is equals to x square upon 2 e raised to minus x, x e raised to x minus derivative of x is 1 e raised to x integration e raised to x dx again. So this is equals to x square by 2 minus x e raised to x into e raised to minus x plus e raised to minus x into e raised to x. This is equals to x square upon 2 minus x plus 1. This is the value of yp. Now y equals to addition of yc plus yp. Where yc equals to c1 plus c2 into e raised to minus x, and yp value x square upon 2 minus x plus 1, putting these two values here. Therefore, the final complete solution is yc plus yp, that is equals to c1 plus c2 e raised to minus x plus x square by 2 minus x plus 1. This is required complete solution.